Good evening. Welcome back to our channel. I am Raju Upadhyay from CIMAGE College, Patna, Department of IT. Today, I am going to talk about a very important topic of Java that is called dynamic method dispatch. Right. So we will be talking about the dynamic method dispatch today, and we will have the implementation part in the later part of the video. So this dynamic method dispatch is a part of method overriding. So as already we know, method overriding is one of the way by which the Java supports runtime polymorphism, right? So dynamic method dispatch is a mechanism by which a call to an overridden method is resolved at runtime rather than at compile time. That means here the binding is happening at runtime. So whenever a method overridden is called through the superclass reference variable, so Java determines which version of that method to be executed, whether it is a superclass or subclass version is to be executed out based upon the type of the object is being referred to at the time of the method call, right? Thus, this determination is made at runtime, not at the time of compilation, right? At runtime, it depends on the type of the object is being referred to, not the type of the reference variable. Mind you, I am saying not the type of the reference variable. A reference variable type could be the parent type, but it can have the reference of their child class, right? So we can say that it depends on the type of the object being referred to that determines which version of an overridden method will be executed, right? A superclass reference variable can refer to a subclass object. That means if you're having so many child classes or subclasses, so instead of declaring separate reference variable for all those child classes or subclasses, we can declare only one reference variable of superclass type, right? And that is capable enough to hold the reference of any one of their child class object, right? So this is also known as upcasting. So this process is going to be called as upcasting, where parent class reference variable can refer it or it can hold the address or reference of their child class object. So Java uses this fact to resolve call to overridden method at runtime only. Therefore, if a superclass contains a method that is overridden by their corresponding child classes or subclasses, then when the different type objects are being referred to through a superclass reference variable, so different version of the methods are going to be executed out. So let us understand everything in detail through the implementation. This was only the conceptual part. Now I'm going to take you for the implementation. In order to understand the concept of implementation, I'll take you to my terminal window where I can go for demonstration. So just I'm going to share my screen to everyone, right? So just hold for some time. Meanwhile, I'm going to share it. I hope my Notepad++ window is visible to everyone, right? So here I'll be start writing code. So I'm going to have one parent class and two child classes of the parent class. That means I'm going to have the hierarchical inheritance out here. So let's say I'm going to write a class here like class A, right? And within this, I'm going to have a certain methods. So within this, I'm going to have a method. So I can give a user-friendly name like void. If this is a method, so I can write M1. This is the name of the method which I have given. And within this, I'm going to have one message like system.out.println. And there I can have a common or standard message. I can write inside is, that means A is the name of a class, is M1 method. right? And then we'll be having another class. This class is over. So I'm going to consider this particular class A as a parent class. From this parent class, I'm going to create two more classes in order to implement the hierarchical inheritance. I'll be writing class B. Clear? Class B. Definitely, it is going to be extends from class A, which I already have created. Within this, I'll be having a method, right? So I'll be having again the similar kind of method. That means the method which we have written in class A as a M1, we are going to override here in class B, right? So in the class B, we are going to override it. Clear? So I'm going to override it here by changing their values. So here I'll say inside is of M1 method. That means this M1 method belongs to class B, right? And inside this class B, this class B has been extended from the class A. Within this, we are having an overrated method of class A as M1. Let us create another class, class C. Right. So here I'm going to create a class called class C. This is also going to be inherited from class A. And here also, I'm going to override this parent class method, right? So I'm going to have a parent class method out here. And here I'm going to write, this is inside a class C. So I'll be writing inside C's M1 method, right? So far I have created three classes. One is parent class called class A. And from the class A, I have inherited a class B, where the parent class method is being overridden out here inside class B. And the same class A has been extended to the class C. And in the class C also, I have overriding the method M1 of class A, right? So after doing this, now we have to go for a proper, a different class called from where we are going to have this dynamic method dispatch demo. So for that, I'm going to create another class called class dispatch. I'm giving a user-friendly name, right? Class dispatch, right? And within this class, I'm going to do every call, right? So here I'm going to write, I'm going to first create an object of class A. So this is a class name. Reference variable is small a equal to new A, right? And after that, I'll be creating an object of class B. So I'll be writing class name B, reference variable is small b equal to new B, right? And one more class we have created, that is called class C. The reference variable is C. And this is getting initialized like this. So we have created three objects of class A, B, and C respectively. And their reference variables are like A, B, and C. Now I'm going to create one more reference variable of class A, right? So how we can do this? We can create a variable here like class A followed by the reference variable name is a ref. For the time being, this reference variable ref is nowhere pointing. That means at this moment, it is pointing to null, right? Now I'm going to initialize this. So here, if I say ref, that means ref is going to be initialized with a reference variable of parent that is called A. That means at this time, it is going to refer to a object of class A, right? And if I say, right, if I say out here, ref dot M1, that means it is going to call, clear, it is going to call A's version of M1. That means A's version means just you see inside the class A, I have created a method called M1. So this M1 method is going to be called as a part of this, it is going to display a message call inside A's M1 method, right? So this is going to be referred here. So let us take further. Now I am going to initialize this same ref variable with a reference variable of class B, right? So now this reference variable is referring not to class A, it is going to refer reference to a particular object of class B, right? Now, from this, if I'm going to call ref dot C1, sorry, M1, that is my method name. So this is going to call a method of a class B M1, right? Now, after that, again, I'm changing the reference of this reference variable ref equal to C, that is a reference variable of class C. And then if we call ref dot C1. So it is going to call, sorry, not C1, M1. Now it is going to call a reference of, it is going to call the M1 version of class C, right? So this is the way by which we can call it. That means whenever you are going to get the output, so first of all, you'll be getting the output, you are going to call the method M1. Right now, this ref variable is referring to object of class A, clear? Then the same reference variable is referring to the object of class B. So the class B version of M1 is going to be called. And then the same reference variable is going to be refer to class C object. And now if we are going to call ref.m1, that means the class C's version is class C's, the C class object method M1 is going to be called here, right? So let us save and execute it. And obviously, we have to write everything inside the main method. That is very important. So that was missing so far. So I'll be writing out here public static void main, right? And within this, the mandatory parameter I have to give string, let's say args, right? And then opening curly braces has to be start, and it should be end with, it should be end here. So this is the closing curly braces of main, and this is the closing curly braces of my dispatch class, right? So obviously we need to save this particular program with dispatch.java, right? So what I'll do is I'll be saving it, save as. I'll be saving somewhere. Let's say I'm going to save in a folder called applet. Anywhere you can save it. So right now I'm saving in that folder. And obviously my file name is going to be dispatch.java. Once it is done, we can check it out, right? So what I can do is I can go to command prompt. Now, in order to go to the command prompt, I need to share my screen once again. So let me open the command prompt. Now I'm going to share another screen. So let me share the screen. Yeah, screen is visible to everyone now. Now let us compile this program. So I'll say Java C followed by name of a class. There is no error. So I'll say Java, followed by name of a dot class file, and you can get the output. So here we are getting is version of class A's object M1 method is going to be called, then class B's object M1 method is called, and class C's object M1 method is called. So here the association with the class and association of a method with the object is happening at runtime. That means here you can see dynamically your method is getting dispatched to a object like this. So here at the time of running, here we have created a reference variable of class A. First of all, reference variable of class A is referring to object of A class. Then we are calling the method of class A object. Then the same reference variable is referring to class B object. And then we are calling a method M1 of class B object. Right. And this is happening not at the time of compilation. It is happening at the time of running of an application. So this is a great example of dynamic method dispatch. This is a very, very important concept and very important question for all university kind of examination, as well as these are the questions which is being generally asked during the interview session. Right. That's all for the day. If you have not liked my video, please like this particular video. And if you have any sort of question, you can ask the question in the comment section, right? And if you are a new user, or if you new viewers for this particular channel, so you can like my channel, you can subscribe my channel, and you don't forget to click on bell icon. So once you click the bell icon, automatically whenever I'll upload the video, and directly this video content will be, or notification will be given back to you. Thanks for watching this particular video. I'll be coming with the new video of Java with the interesting feature. Thanks a lot once again.